In this video, we are going to talk about data transformation. So if you see in the last couple of videos, we spoke about data collection, where we are taking the data and centralizing the data. And then we spoke about data analysis, where we use the centralized data to identify trends and patterns, right? And further, like one of the input to the data transformation phase is your data analysis. So basically, a data analyst go through the data, tries to generate some descriptive and inferential statistics, and try to come up with transformations that can identify the outcome better of a machine learning model. Right. So that's where the data transformation input comes from. But said that your data analysis is not only one input to the data transformation phase. So the data transformation input can come from your domain understanding team. It can be a business who understands the domain well, who already knows the attribute and can tell, okay, these are the different things that is happening in the current system that can enhance your model better. That is one part of it. There can be industry focused method. When I say industry focused method, if you see typically in the investment management space, right, there are predefined formulas that are available that we use for performance measurement of a portfolio or something like that. Or even in the regulatory space, you have all the calculation like loss given default, probability of default, exposure as their default, these kind of predefined formulas. That can also be one of the input to the data transformation phase. Now, the data transformation can come even from the further phases. So basically, a machine learning engineer, when he goes to the data and identifies a new pattern out of it, something which the data analyst might not have seen it. So basically, now when we specifically talk about future engineering, there are two parts to it. The first part is the future engineering that we do to overcome the model limitation. A typical example is numerical encoding. Your machine learning model can understand only numerics. So you do kind of a numerical encoding over there, or it can be a one-hot encoding. We take the data and kind of split into multiple variables so that the model does not understand as a order to the incoming data, right? Or it can be scaling that can speed up some of the algorithms. So these are all model dependent or something required for the machine learning model to perform. The second one is that comes from the domain understanding of it. So the domain understanding, once you explore the data, you can actually find new patterns. And what you want to do, you want to kind of take these patterns and build a scalable pipeline. Sometimes this calculation are pretty complex and you need to deal with huge data set. And doing it in a kind of Python language or R language can be very cumbersome. So you want to go to more a distributed processing like Spark or something else, right? So that's where what the machine learning engineer does is he takes those transformation and pass it on to a data engineer team who can build a single scalable pipeline that can be easily deployed, right? That is one part. That is the second part of it. Now, if you come back to the first part of it, the pre-processing part of it, that is, I spoke about future engineering that is required for model to perform. Typically, those must be kept outside of the data transformation phase. That must be done within the ML code, like scaling, one-hot encoding. This should not be done as part of the data transformation layer. It must be done within your machine learning code that you write to train the model. Right. So these are multiple aspects of input that can feed into a data transformation phase. Now, this data transformation phase or data transformation layer can be used not only by machine learning, but can be used by reports, dashboards, or anything that you use. Right. In the context of future engineering, if you see like the data transformation phase, a lot of companies today call this as feature store or feature store, right? If you see Uber, Michelangelo platform, they are something called feature store, and those are pre-aggregated, predefined features built using scalable pipelines that the data scientists can use, and they don't have to worry about engineering their own pipeline. And this makes even deployment easy in the future. Now, coming back to the previous data collection, we just spoke about this architecture, right? We have a data in the system of record. You collect the data can be collected in batch, real time, or API layer, and then you kind of store the data, right? In between, you have data standardizer. I'm going to simplify this diagram for this particular video. So if you see the same diagram, you have the system of record. You collect the data collection can be batch, real time. You have finally a raw data store. So your data is still pretty raw. There is no transformation done. The raw data resembles what it is in the source. The only thing we additionally might do is the standardization of data. So what does this standardization mean? So now if you see in the system of record, the data can be in multiple formats. The data can be basically in a COBOL copybook. The data can be in an XML file, JSON file. So rather than taking and dumping the data as it is, we are standardizing it into one common format. It can be a Parquet format, it can be an ORC format, the format that works well with your platform, and the format also that can work well with the computing ecosystem, right? So that's what the raw data store is about. You standardize and load it into a single format. The advantage of this is the consuming application like the data scientist or BI does not have to worry about converting it to a common format and then using it. So once you have your data in the raw data store, you organize the data. Again, organization of data is optional. So data organization means bringing some attributes into a common format. So if you see, like when you talk about multiple SOR system, every system has its own date format. This is the simplest of examples. You want to kind of convert all the data into a common format like MMDDYYY, right? There might be also data duplication across the system, right? You may, for example, a typical banking credit bureau, credit data comes from 3 different providers. So you may want to kind of build an master data management layer that kind of provides a single source of truth. It can be also some duplication in your system like foreign exchange rates or something like that, where you want to identify your source of truth. Basically, data organization layer is kind of taking the data from the raw data store and providing a single source of truth that your downstream application can use. So, and it's not necessary, but it's good to have it if your data is single data element or single data sources spread across 10 different systems. Or take a customer. A investment banking may have their own customer record. A retail banking may have their own customer record. So basically, your customer data is spread across multiple systems. You may kind of want to create a one single layer of customer having a consolidated entity, because the same customer may be your investment banking customer or it can be your retail customer, right? So you want a single layer. So that's why the data organization layer comes into play. Once your data organization done, you build your data transformation. And the data transformation, as I said in the previous slide, can be an input from your data analyst, can be your input from your business domain analyst, can be an input from basically an industry defined calculation, or it can be a input from your machine learning engineer who finds new pattern as he does more feature engineering. Right, so that's the data transformation store. And in the context of machine learning, we can call it as a future store. All right. And now, if you see in the bottom, that's where the data scientist, the analytics layer is where the data scientists typically use tools and techniques to build their model. So what they do is they use data from the transformation layer as well as the raw data store. Right. Now, why raw data store? Because some of the data that originates in your source, right? When you take a model, there will be 2 different data. So one that originates in real time and one that you refer in the batch, right? So in this case, what originates from the real time, you don't want any kind of handling to be done in the data. You don't want any data quality or anything that needs to be done. You want to handle that within your model, right? So basically, data analysts may refer those kind of sources in the raw data store, and you might need some engineered data, right? So say take example, I'm trying to find whether a customer will revisit my store. I'm a Walmart and I want to see whether a customer will come to my store again in the next 30 days. So I build features to understand the recency of the customer and the frequency of the customer. So basically, I may create variables. What is the number of times the customer has visited in last 2 days? What is the number of times the customer has visited in the last 4 days, 7 days, 9 days, 10 days, 30 days? So I'm kind of getting the frequency, right? And when did he last visit me? That may be recency. So those kind of engineered features, rather than building at the model, you are building predefined pipelines, because these are all not real-time data that you need to calculate. You can refer to as batch information, right? I'm going to cover this more detail in a separate session when I go to machine learning called a training deployment queue. But for now, you think that the analytics layer can get data from both the data transformation layer as well as the raw data store layer. And that's when you start building your model over here, right? So typically, data transformation is pre-calculated, aggregated features that you can directly use in your model rather than worrying about building it for each and every machine learning model. So what I meant to say is the same features can also be used across multiple machine learning models. So if you take typically a risk model, you may calculate risk of a customer, or you may calculate probability of default of a customer, or you may you may do a dashboarding to show the risk. So rather than calculating it within your application, you are pre-building it, centralizing it so that it can be used across applications. So that's about data transformation. We will next go into the machine learning phases in the future videos. We'll more talk about the best practices of machine learning rather than going into more algorithmic details or something like that. Thank you.